kids, Miss Kulkarni here. In this video, let's talk about liquids and solutions and learn more about reaction stoichiometry. So let's begin. First of all, what is molarity? Molarity is defined as number of moles of solute, which is the substance that we dissolve in 1 liter of solution. And as you know, the units are moles per liter, or we represent that as uppercase M. Now, molarity involves moles. That's why we use this along with stoichiometry problems. Because in stoichiometry also, we talk about mole ratio. So how can we calculate molarity? There are two different ways of finding molarity. One simple method is to calculate moles using stoichiometry, and then you divide those by volume in liters, because molarity is nothing but N number of moles divided by liters. You can also interpret the formula number of moles divided by liter as number of moles is equal to 1 liter, and then we can find out how many moles we need to dissolve in given volume of solvent. Alright, let's actually work on a problem which involves reaction stoichiometry and molarity. So what do we got here? We got two compounds, potassium iodide and lead 2 nitrate. So let's write a balanced chemical reaction for both. That's potassium iodide, and lead 2 nitrate will be Pb, and then NO3 will be 2 there. And when we balance the reaction, what do we get? So there you go, you got a balanced reaction. Now what is given to us? We have been given that we have 0.150 molar potassium iodide, but we are in fact beginning with 15 grams of lead 2 nitrate. And then we need to find out how many milliliters of potassium iodide we need to have. Now, just to remind you, what we got here is a mole roadmap or a mole bridge. That means we need to have moles of each compound on each side. So this is moles of, suppose if I call A and B for potassium iodide and lead nitrate, this is moles of B here, and this will be moles of A. So we need to figure out whatever is given to you, how do we get from there to the moles of that substance, then take the mole bridge, and then from other moles we arrive at whatever is required. So let's see how can we get 15 grams into moles of B. So this means we can actually work on this problem in 3 parts, and there are times we can combine any 2 or even all 3 parts together. It's whatever is convenient. So in this problem, I know I can easily begin with mass of B or lead nitrate, and I can easily go from mass to moles of B using the molar mass, of course, and then I can take the mole bridge and I can go to moles of A. Now, although I can go from there to what is required milliliters, it might be good for me if I stop here and find number of moles. So I'm going to stop here and calculate number of moles. Before that, what do I need to get? Grams of B to cancel the grams with grams. And here moles of B, so I need to make sure I have moles of B over here. Anytime we get moles and gram ratio, mole is number 1 and gram corresponds to the molar mass for that compound. And the molar mass for lead nitrate is 331.22 grams. And the mole ratio is the one which comes with the coefficient. So that goes with A or Ki, and no number means it is 1 with respect to B. So let's write down those coefficients, which is 1 and 2. When we solve that, we get the answer 0.0906, and those are moles of A. Now our job is to go from moles of A to finally to milliliters. And for that, we are going to use the molarity formula, which is M is equal to N divided by volume in liters. So molarity is given to us as 0.150. And then number of moles is one which you found, which is 0.0906, and then that divided by volume in liters. The volume which we get, if we calculate that, is 0.604, and our answer needs to be in milliliters. So the last part which is remaining is to convert that volume in milliliters, and you know how to convert that. 0.604 liters will be corresponding to 604 milliliters. So that is the final answer which we got, and we used reaction stoichiometry as well as molarity. Okay, let's practice one more problem. So here we begin. We need to make sure we have a balanced reaction. So let's find out the chemicals. Hydrochloric acid is one chemical and second is calcium hydroxide. So let's get the balanced reaction for both of those. It's HCl, that's the formula, and then calcium hydroxide. And what do we get? So there we go, we got the balanced reaction. And actually I also wrote the starting point, which is 25 milliliters of volume for hydrochloric acid. And we need to find out the final thing is the molarity, which is concentration of calcium hydroxide. So again, this is going to be your mole bridge, and this will be moles of A, and this is going to be moles of B. So there are three components again. We are going to start with what is given, the volume, get to moles of A, then use mole bridge, get to moles of B, and from there again we can use molarity, and then we can get the actual value for concentration for calcium hydroxide. Okay, let's solve this problem in 3 steps. And the first step is going to be using molarity and converting that volume given to the moles. So the formula I'm going to use is molarity is equal to number of moles divided by volume in liters. What do we have? The molarity is given to us for HCl, which is 0.1234. We need to get the number of moles, and then the volume is given 25 milliliters. 25 milliliters equals 0.025 liters. So when we plug that value over here, we got an equation, and if you solve the value for N, that comes out to be 0.00309. Those are the moles for A. Once we got number of moles for A, the second step is going to be going from a mole bridge, moles of A to moles of B. So let's do that conversion. Moles of A is my beginning point, and the end point will be moles of B. And in order to cancel, I need to get moles of A over here. This is the beginning moles which I calculated, which is 0.00309. And then we get these two values by the coefficients from the reaction. So for A, HCl, coefficients are 2, and for B, it is 1 as a coefficient. So what do we get? We get our answer as 0.00154. Now these are moles of B. And that leads us to step number 3. Step number 3 is going from moles of B to the molarity. Again, we are going to use that popular equation. Molarity is number of moles divided by liters. The molarity is something we need to calculate here, but we know number of moles for B, which is 0.00154, and we also know the volume volume is 23.45 milliliter, and if we convert that into liters, that comes 0.02345, and when we solve that, the answer which we get is 0.06578. That is the final molarity of calcium hydroxide. So guess what? You guys learn how to combine reaction stoichiometry and also molarity. So there you go. I hope you guys enjoyed the video. I'll see you in next video. Until then, bye bye.